Welcome, my name is Dr. DrWedding, and this is DrWedding DC06. Understanding the difference between AC and DC. In this short video, you will learn the difference between AC and DC. In this series, all of the circuits will be DC. However, it is important to know the difference. DC literally stands for direct current. The initials DC have been used for so long that it now just means direct or one-way. That is why people say DC voltage when they mean direct voltage, and when they say DC current, they mean direct current. If you expand DC into direct current and use it in front of voltage and current, it sounds funny. DC voltage becomes direct current voltage, and DC current becomes direct current. Therefore, even though DC stands for direct current, you should think of it as just direct or one-way. AC literally stands for alternating current. The initials AC have been used for so long that it now just means alternating. That is why people say AC voltage when they mean alternating voltage, and when they say AC current, they mean alternating current. Just like the example with DC, if you expand AC into alternating current and use it in front of voltage and current, it sounds funny. AC voltage becomes alternating current voltage, and AC current becomes alternating current. Therefore, even though AC stands for alternating current, you should think of it as just alternating. In the previous video, voltage, current, and resistance were all explained using the analogy of a bucket of water on a shelf. In this video, a similar analogy will be used. In this video, DC will be described as a slide on a playground. The analogy of the shelf and the slide are essentially the same. The height of the slide is the voltage. This is just like the height of the shelf was the voltage in the previous explanation. And instead of water leaking out of the bucket, this time we will pour marbles down the slide. Unlike the bucket of water on the shelf, the slide analogy does not have a good way to explain resistance. However, the slide analogy does a better job explaining the difference between DC and AC. In this example, the height of the slide is the DC voltage, and the marbles going down the slide represent the current. DC has a fixed voltage that does not change with time, just like the height of the slide does not change. A slide that is 6 feet tall will remain 6 feet tall today, tomorrow, next week, and next year. The DC current only flows in one direction. In this example, the marbles will roll from the high side of the slide down to the ground, and they never change direction. AC is a bit more complicated to explain. To understand AC, think of a teeter-totter, also called a seesaw, on a playground. There are marbles on the bar that moves up and down. On the right side of the bar is a red dot that will be used as a reference point. There is also a perfectly horizontal dotted line. Step 1. When the bar is level, the marbles do not move. This is the same as 0 volts, because the difference in height from the red dot on the right side of the bar to the flat dotted line is 0. This also means that the marbles are not moving, so the current is also 0. Step 2. When the right side of the bar, with the red dot, starts to go up, the marbles start to roll downhill. This small rise represents a small voltage, and that causes a small current. We say the marbles are rolling away from the high side because we are discussing this in terms of conventional current flow. Step 3. As the right side of the seesaw gets higher and higher, the marbles move faster and faster to the left. This is equivalent to the voltage increasing. And as the voltage increases, the current increases too. Eventually, the right side is at its maximum height. This means the voltage is at a maximum and the current is at a maximum. Step 4. After the seesaw reaches its maximum height, it starts to come back down. As the right side of the seesaw comes down, the voltage gets smaller. As the voltage gets smaller, the current decreases. Step 5. When the seesaw bar becomes horizontal again, the marbles stop rolling. This is the same as the voltage going back to 0. And when the voltage is 0, the current stops. Step 6. When the right side of the seesaw goes lower than the left side, the marbles start to roll again, this time in the other direction. This is equivalent to a negative voltage and a negative current. Keep in mind, the negative sign on the current only means a change in direction. Step 7. When the right side is at its lowest point, the marbles are rolling at their maximum speed. This is equivalent to the maximum negative voltage causing the maximum negative current. When discussing current, positive and negative describe direction. In this example, when the marbles are moving right to left, the current is positive. And when the marbles are moving left to right, the current is negative. Step 8. When the right side of the seesaw bar starts to come back up again, the marbles slow down. This is equivalent to a smaller voltage producing a smaller current. Step 9. When the seesaw becomes level again, the marbles come to a stop. This is equivalent to the voltage equaling 0, and therefore there is no current. At this point, the cycle will repeat. If these 9 steps are plotted on a graph, you will see that the sequence will create a sine wave. This will cause the current to move in one direction when the voltage is positive. The current will then change direction when the voltage is negative. AC current is constantly changing direction. It is very important to understand that there is a difference between DC and AC. At this point, you should understand the differences. In this video series, we will only discuss DC voltage and current. In future videos, AC voltage and current will be covered. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This is the only way I can continue to make these videos.